Now, before we get into today's video, I just want to take a minute and say, don't. Just don't. Don't watch it. Don't even think about watching it. You're probably going to burst into flames just thinking about watching this video. There's such poor workmanship. Somebody's panties are going to get up in a bunch, and we know they're panties because we know about your side gig. So just stop it now. Don't waste the next 40 minutes of your life watching me ramble and build crap out of garbage and, I don't know, just stop. Just don't do it. Move on. Well, today on the healing bench, I have something that's been a little bit of a thorn in my side the last month. So I figured I'd take you along and show you how to repair things with busted 18650s in them. And today that's going to be this piano scooter. So this thing had a cell crap out on it a while ago, and all I had were some cells that didn't have that much capacity in it to replace it. And so there were a group of cells in this 36 volt pack that one went bad in, so I replaced those three, and all I had was some about 2500 milliamp cells, and so I've got some 35s and I want to replace that group. So I just figured I'd show you what you got to go through if you have something that has reduced range or just discharges. The percentage that it says that it's charged doesn't match up with the actual range you're getting. Something's up in there. You obviously know something's up in there. So I want to show you how simple it is, or how hard it is, to replace a group of cells in something like this, because it's usually, these things are filled with Chinesium cells, and just one of them's gone bad, and they're sapping down one group. And you'll see one of the series strings has low voltage, and then you can tell that's it. If you pull them out and you have a little $10, $15 battery tester to test the internal resistance and capacity test them, you just pop them in that thing, and then you'll know you definitely got the right group of cells, because the voltage in that one particular string is going to be off. And then you can just solder in or weld in a few new cells from a drill pack, or however you get your cheap 18650s. I like to go to 18650 store, or batteryhookup.com is another cheap place to buy cells, and toss them in there. So let me get this thing unscrewed. Oh boy. Being the man that I am, all the screws are ground down on the bottom because I drive like a lunatic. Pretty much everything I own. Anybody knows me, they know that's true. So it's not to be a real pain in the butt to get the screws out. I'll give it a shot anyway. I'm not promising I won't cuss. Oh yeah. Oh yeah, this is gonna be not fun. Well, let me check back in with you whenever I've got the rest of these screws out, because this is obviously going to suck. Alright, so now we got the cover off. I promise I only cussed 10 to 15 times doing that. Unscrewed the battery pack, took the lid off, and here's this work of art. So a lot of these scooter battery packs are 36 volt, and like this one, you'll see they are a 10S or 3P10S configuration, meaning you got 3 cells in parallel, and then they series through 10 groups. 3.6 nominal voltage times 10 makes a 36 volt pack. So all we have to do is, it's already been done once on this pack, is come along here and check each one of these bundles, what the voltage is in each one, and see if we have an outlier in the group. So let's see if we do. Hopefully we don't, but since I have some unmatched cells in there, the ones on the end will probably be a little bit off. So let's see if that's the case. If y'all can see that. Can you see that? Let me know in the comments. So just go through here and check each one of these groups. 401, 399, 401, 400, 401, 4, 4, 4, 4, 402. So we don't have a standout in there. So typically, if you have something that's going dead on you, the range just isn't what it used to be. Typically, if you take this apart while it's at its lower end of its charge, you'll see clearly that one cell, once the BMS has dropped out, you're going along. Uh, you're getting towards the end of the range or where it normally kicks off. Boom, it kicks out. The BMS has detected one of these cells has gotten below whatever voltage it's set to, maybe 3 volts or whatnot, and it drops out. So when you come in here and you test all these, you're going to see, I'll cover up this horrible wound in my hand so you don't have to stare at that. You'll see one of these is significantly lower than the others. So what do you do at that point? You can assume that all of the cells in that group are bad. That may or may not be the case. Or you can experiment around and actually, take this whole group out. Take your dikes and very carefully peel back all the tabbing here. You can see this has been crappily re-welded by my little battery welder. Peel all this off very carefully without touching anything else adjacent, or you're going to have some huge sparks and whatnot. And take those 3 cells out, put them, if you've got a little charger battery analyzer that's like $15, let it run through its capacity test, see what the capacity of each one of those batteries are, and it'll tell you what the internal resistance is. And then from there, you can decide, do I just want to replace one cell in that little group of cells, which is kind of silly, or do I want to replace all 3? I would just say just go ahead and buy however many group there are. But you need to have a matching capacity. I didn't do that in this case, so I replaced, these are 3,500 milliamp cells, and I had some, these are 28s or 2,500 milliamp cells laying around, and I just threw them in there. So basically my capacity is limited to 2,500. This is always going to be the one that charges first and the one that always goes dead first. So I basically just chopped, a huge percentage of range out of the pack. So whenever you're doing this, you can take one of the cells out from one of the other parts of the string and capacity test it and confirm roughly what it is. But you can look up the serial number, not the serial number, but the model number of the cells and pull the data sheet. Or sometimes it's printed right on there in milliamp hours or in watt hours. And you can see these have 12.6 watt hours. I don't know if you can see that on the label. This is actually printed directly on there. Sometimes it's right in the serial number. It'll say yada 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 3,500, yada 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 2,600, something like that. In this case, it has both. It has 12.6 watt hours and 3,500 in the model number. So it's a 3,500 milliamp cell. So you need the biggest. 3,500 is the upper end of what's available in an 18. Your off the shelf 18650. So that's going to be pretty typical. They're trying to get some range in this little pack, so they're going to be bigger cells. And these, what are they? We'll find out once I peel them apart. I know they ain't 3,500s. I know that for sure. They ain't got no range, and they were new. They were out of a drill pack that I bought. That was for something else that was brand new. So I think they're 2,600s or something like that. So I'm gonna cut this group of cells out of here, and we'll take a gander at them and see what we got. You got to be super careful when you're messing with this stuff. If you look on the positive side of the terminal of these batteries, it's super easy to short these things out when you're playing with them, because this is the positive end, this is the negative end. It's pretty easy to keep everything cool on the negative end. It's just this is one continuous part of the case. So if you mash around here or anything, unless you hit an adjacent cell, nothing's going to happen. But on the positive side, you got the positive, but the negative side of the case is crimped right here too. So there's this isolator, but if you go prying around in here like this with a screwdriver or something like that, and you pierce this right here, you'll short the positive to the negative underneath here, and there'll be a little fireworks show for you. So don't do that. So you have to be kind of, I'm pretty reckless with it because I'm just stupid. But the the best way I've come up with these welded on types of cells is kind of get in here with a small screwdriver and bend the tabbing up, and then take a pair of dikes and kind of the roll it off and peel it off away from the battery without pushing down into this area right here, or it'll do like what I said earlier. Let me get a little right head, you know. So here's your quandary. Where do we pry up on this, right? Because your instinct is going to be to stick the screwdriver in here and jam like that, and you're going to short the battery. So we got a little spot in the plastic here, and these are very poorly spot welded by yours truly. So we can get in here and peel them off. And then when you're prying it, don't press into the side of the cell. Pull away from it. And then kind of work your way around. And you'll get to see if I make any of the mistakes that I just told you not to do, which will be pretty likely. Because I do as I do, but not as I say, as I do what I do when I'm doing stuff. Whatever. So, oh, see, right there. That's what happens. I didn't really have anything to lean up against, so I did exactly what I told you not to do. And that's what happens. And if you go in there, get real crazy, you could cause some runaway effect. Most of the time, most 18650s, they have a current limiting device underneath here. So unless you do something really wacky, it usually doesn't lead to anything bad. But if you pierce these things, they'll internally thermally run away because the little layers inside will get smushed together, and then you're in trouble. It's even if you just waste one cell, I mean, it's going to be a fireworks show. So be careful. Of course, this is 15 times harder doing this while my head's not in the camera and I can't really get down there and pay attention to what the hell I'm doing. So I'm way more likely to screw this up on camera, but you get to see all the good and the bad. Actually, I have to re-weld this one over here. It's coming off the battery because I did such a great job with my crappy welder last time. That we got. Man, it'd be better if I could get my head down the shot, but doing this for you, man. Okay. So this one, cut that off a little bit. Get a little bit cleaner. Wow, this is really poorly done. Okay. I don't know how much whiskey I had last time I welded these 3 cells in there, but it must have been quite a bit. I think I'm going to go ahead and cut this one off too. Peel this back. That's going the output to the BMS. Alright, so this side's cleared out. Let's get to the other side. Man, that is a really bad job. Now we're on the negative side, so we can get a little bit more reckless because we don't have to worry about pushing up against that side of the case or whatnot. So I really should have a nice set of end cutters, but I don't. So it's just mangle it away. And I think we can just push these out probably all together. Just deal with them all in a group. So there's your group. There's your group of crap. So we'll just pull these apart. Clean the ends up. So these are still usable cells. I'll probably just do something stupid with them. But they are still functional, really good cells. I mean, they may have been cycled like 20 times or something since I put this back in there. Or 50 or 60, who knows. So we got these lower capacity cells. We'll pretend that these were bad. In your case, they would have been. So you can have, without having a internal resistance tester, you can just test the voltage of each one of those in that group of cells to see is one of them actually different than the other. 402 402. I don't know if you can see that. 402, 402, 402. Sure. Yeah. So in this case, they're fine. But if you had one dead cell in all this, you're going to notice one of them's out of whack. Now, you can have things that have a similar voltage and they have very low capacity. Just because where in the state of charge you are, they may show a similar voltage, but the actual capacity is way off. So you need to test these, and the only way that you can really test them is properly is to cycle them in a tester and actually see how many amps come and go out of the battery, see how many actual milliamp hours you have in capacity to know that you've got a good one or a bad one. Now you can make a pretty quick analysis through just checking their internal resistance. Now, if they're in a reasonably high state of charge, you can use an internal resistance tester. I've got a high accuracy one here, but this is probably above what you're going to have unless you work on this sort of stuff. But those little $15, $20 battery analyzers typically will tell you what the internal resistance is right away. But if you got one of those, go ahead and put it in there and cycle it anyway, see what the true capacity is, and then you'll know either way. So you'll have the internal resistance and the capacity, so you know exactly what's going on with each cell. With these, you can see 22 milliohm. 31. Well, that's a little bit of a disparity for cells that were in parallel. 31. Come on. I've really jacked up the tips on these things over the time. 30. 30? 30-ish. And what was this guy? Oh, what the hell is going on with this guy? All right. I know that's not a proper reading. What's going on here? $22. Okay. 22, 30, and 30. Now, if you're in an upper end state of charge, say you're over 3.6 volts on each cell, 20 to 40 for most 18650s, 20 to 40 milliohm is going to be a reasonable capacity. You're going to have reasonable capacity. You're not going to see that in the 20 to 40 range with them charged up. You're not going to throw them in your capacity tester and then they just have nothing. If they were going to be really bunk, you'd know right out the gate that that's going to be 80, 100, 150 plus milliohms on a bad cell that's got serious degradation on it. So we know these are still good, so I'll put these aside. Now it's really important that when you put the cells in here, and when you replace these cells, that you have them at a very, very similar state of charge. Now, my laziness is going to kick in pretty good on this one. The battery management system that's in here, if it's properly engineered, it's got a decent amount of balancing current, and if you have them, at a very high state of charge or a very low state of charge together, then as this charges up and you have it leave it on the charger for a little while, a little bleeder resistor will come in and drain down whichever cell is highest and keep them in balance. But it's cheap Chinese garbage. You don't know what that balancing current is, so it's best that you start out with them as close as possible. And so don't put them in there at a nominal voltage, like say lithium ion 3.6, 3.7 nominal voltage. Well, you stick 3 in that are at 3.6 and the rest of them are at 3.6. It could be it could be plus minus 20%. So it's going to take, even if the balancer was acting right, it's going to take a long time for that thing to actually trim the pack and get it back in balance, especially if you've just got one that's low rather than high. Then all these got to come down if it's just using a bleeder resistor. So you can tell much easier at a high state of charge or a low state of charge what the actual state of charge of the cells are. So it'd be best if you charge the whole thing up, plug the scooter in if it's still working, or whatever device it is, let it charge all the way up until it stops charging, and then take the cells that you're going to install, put them in your cell tester, charge them all up to full capacity as well. So everything is going to be, probably, once it's back down to a resting voltage, maybe 3.8 volts or so. And they're on the upper end of the capacity before you get started, or that's just it's gonna take forever for it to balance. You're still gonna have reduced range while it's trying to do balancing, and if they're not that close, then they may not ever balance. So definitely do that. All right, cells are almost charged, so getting ready to put this thing back together, but I figure we might as well check the internal resistance of the rest of this pack just for shits and giggles. So all right, let's try it on this end. Okay, 11 milliohm. All right, check this one. 11 milliohm. 11 milliohm. Where are you at over there? Well, probe's jumping all over the place. I just ran through this earlier, so I know this is not the case. Just my probe is worn out. Edge mash 11. All right. I seen it. You seen it. Everybody done seen it. 11. Okay. Or 10.8. So they're all 11. So they're in a high state of charge. Anything, under 40s, good. These are 3 in parallel, so the resistance is going to be even lower. I think they're individually probably around 25 or something like that. So yeah, that all looks normal. Let's throw these cells back in there. See if we can not cause too many sparks. All right. Before I go sticking these in there, let's give them a quick test. I'm doing this pretty down and dirty for the camera, trying to get it over with quickly. So pay way more attention to what you're doing than I'm doing right now. Sit down, take your time, clean up these batteries real nice, or nice and flat. So when you're using your welder or your soldering iron, I would hope you got a little welder, but you can solder them on there. You got something that'll work. This is embarrassing. I'm pretty embarrassed. I took this apart. I knew it was gonna be pretty bad, but yikes, that's pretty rough. Anywho, so, and look, they're even pink. It was meant to be. But I love this little warning message on this one. I haven't seen this before. Maybe this is more common or maybe I've been out of the game too long. It's been a while since I've been messing with 18650s on a regular basis. Fire hazard. Not for vape. All right, so maybe they're not high discharge cells. Well, this thing's only pulls 10 amps continuous because it's a 350 watt motor on 36 volt pack, so it's only a little under 10 amps peak, hopefully. So hopefully they can handle 3 amps each. Not for vape. Never install. Well, I mean, how the hell else are you going to use it? Never install, carry, or handle. Well, we're breaking all the rules today. We're going to carry them, handle them, and install them. Well, we didn't break that. We're not going to vape with them. So we're not breaking all the rules, but I mean, I break as many as I can and try to do it all at once to increase your pucker factor. So yeah, that's the right polarity. Here's our positives. So the next one's going to be negative up. Here's a little jumper that's going uh, up to the main board there. So we got to tie these together real good like with our crappy welder, and it probably would make more sense to fire up my high current soldering iron and do this, because this battery welder is just not chooching the way it used to. I don't know. I'll use that as my excuse, just like a crappy welder. You just got to get good at grinding is all. So, see, I mean, this thing, crank it up all the way. I'm going to show you how crappy this thing is. It choots pretty good whenever I got it new, but she's been loaned out about 3 or 4 times, and I've put together quite a few packs with it. I just don't build 18650 packs really anymore. I build lots of lithium iron phosphate packs, but not with cylindrical cells, with prismatic cells. So, I mean, it's hard to justify buying a nice battery welder for something that gets loaned out for use more than it does actually get used. I just can't justify it. So a bunch of crappy spot welds it is. You know, when they're all bad, you just got to have, I don't know, 15 of them, and you're all good. That looks awful. Next, on to the next one. Alright. Should probably take the time to just solder a whole new thing on here, because it's going to try to burn through. Turn the juice down a little bit here. It's going to try to burn through welding just the 2 nickel strips together, because there's not a battery on the other side. And that's how you know you're doing something wrong. When you get the little arcs flying off to the side, you know you don't have enough material on the other side. Good enough for government work. Yeah. It's ugly, but it'll work. Nothing looks too out of place. I don't think it'll come loose. Oh, this guy. Yeah. It's fan. That's it. So, from this point, reverse of disassembly. Guess we can turn it on and see if it actually works. Yes, it do. Hopefully, that's a repaired e-scooter. Just make sure you seal these things up the way that they came apart. If you crack the top of the lid of this, silicone all this stuff back together correctly, because it's just a tray in there. Water gets up in here, and you just don't want this stuff sitting in the water. You ride it in the rain one time, and you're gonna have a pool sitting in the bottom of this thing forever, and then enough corrosion and bad things will happen. We got enough fire hazards in our life. I mean, that's enough as it is. So I'll screw it all back together, and pretend like I did a good job, and move on to the next project. Now, if you made it through the whole video, I'd like to say kudos to you. And, you know, get a life. I mean, what are you, some kind of sick stalker or something? I mean, who really has that kind of time to watch me ramble about shit like that? So, thank you, and don't do it again. Somebody's going to find out about this. And you don't want that.